Okay, welcome everyone to the graveyard shift. I thought it'd just be me and the cleaner, to be honest, because not only have we got that end of the day session, but I'm talking about networking, right? So probably one of the most exciting sessions you're going to come to this week. My name's Steve Morgan. I work for Microsoft here in the UK. Had about 20 years in industry working with SQL before I joined Microsoft about 5 years ago. And I'm a data platform or database architect, right? So I've worked with a lot of database platforms over the years, but I'm a SQL Server guy at heart, right? I trained as a SQL Server DBA and then sort of spread my wings onto other platforms, but SQL was always at the heart of it. So just before I go on, a shameless plug. A free full-day event that I'm hosting on the 26th, joined by some of my Microsoft colleagues. If you're interested in migrating SQL databases into Azure, just come along, snap the QR code. I've just been told before I've come on that the reg page isn't up yet. It's a holding page. But if you snap it and go there in about a week, you'll be able to actually register for the event. So we spend a full day talking about the reasons to modernize, why you should think about moving to the PaaS flavors of SQL, what those PaaS flavors are, before we actually go through the migration process itself. So we look at the tools, we look at the output, we actually see some, we do some live migrations for you up into Azure. And then we also think, we come at this because we've all come from an industry background, we know you don't just move the database by itself, right? So we cover some of the other parts of the SQL stack, like, well, what do I do with my sys packages? And we show you how to move those as well, right? And then in the end of the day, or the last couple of sessions of the day, we deal with the sort of DBA type tasks around security, backups, patching, all that kind of stuff, right? So free event, open to anybody, no limit on numbers, bring your colleagues, bring your family, bring your kids, bring whoever you want, okay? So that's on Tuesday the 26th. Okay, so this is what we're going to talk about today. We're going to be talking about networking, and this really comes from my own pain, right? I was a database engineer, as that's the modern term for it, for many years, and didn't really have to bother about the network, right? That was somebody else's job. But then when we started moving databases into Azure, and particularly with the PaaS flavors of SQL, suddenly you need to start understanding bits. So this is what we're going to try and demystify today. However, I will caveat, I am not a network engineer, right? So don't ask, there will be bits where I say, it just works like that, because it just works, right? I don't know how it works. That's the magic of the network, right? But I just want to try and demystify some of the common topics around securing and isolating your PaaS databases in Azure. So we're going to talk about that, and then we're actually going to go through some demo-heavy sessions where we look at the different connectivity mechanisms to Azure SQL Database and Azure SQL Managed Instance. Okay, I'm not dealing with VMs because VMs just live in a network, and that's they're not really any different. Okay. That's the QR code for the session feedback. So, don't give me feedback right now, obviously, because we've only just started, but I'll flash it up again at the end on the QA page. So just do give me feedback, and we'll see how that goes. Okay, so back in the day, DBAs didn't really need to care about networking, right? As far as we were concerned, when I was deploying SQL Server onto a box that the infrastructure team had already given me and probably pre-installed the operating system and configured, the SQL boxes, the bit of wire between them was just the wet string, right, that connected two endpoints. As long as my two servers could actually talk to each other, and my sys packages on one box or the link servers or whatever it was, a client application, could see the other box, I was fine, right? Didn't really care. The only time I cared about it was when it didn't work properly, when performance was bad. And even in that situation, we never really got involved, right? Because if the network was performing slow and my batch jobs were taking ages to drag the files, or it was taking ages to write my backup files to some remote server, all I'd do is raise a ticket, right? And if the guys in the engineering team and infrastructure or whatever didn't get on the case quick enough, I'd go around and knock on the door or the desk and start moaning at them. Right? About the closest I ever got to it was when we were using a SAN backend for some databases back in the day. And the SAN engineers promised me I'd get 100 megasecond throughput. And I was using SQL.io to prove I was only getting 20 meg. And, and so we had to try and diagnose this issue, And it turned out to be, this is pre-VM days, right? But this was, it turned out to be a misconfigured NIC in the back of the host, right, in the back of the server. And to be fair, I didn't get that involved with it. All I kept doing was running SQL.io and telling them it's still 20 megasecond. Fix it, fix it, fix it. Okay? So we just didn't really care. As long as they could talk to each other and see each other and we could move the traffic where we needed to, then that was fine. However, now that we're running these fully managed SQL PaaS services and other PaaS versions of databases, I'm not going to go into those now, we do have to care, right? So there's a few things that we have to get involved in. So we have to understand why public cloud and public databases aren't public. And we have to be able to have that conversation with naysayers, right? And with people that are trying to block us from cloud adoption, because there is security in them. We're going to see that shortly. It's just it looks a bit different to what they're used to, okay? We have to talk about these things called endpoints, right? And it's just this really woolly, vague, ephemeral term that literally means, you know, anything at the opposite end, anything at the end of something, right? So it's just we have to get used to some of this kind of uncomfortable language sometimes as well. And probably worst of all, there aren't any network engineers in here, are there? You know, we have to have conversations with network engineers, and we have to be able to speak the same language, right? To use a good old SQL analogy, there has to be a Venn diagram of understanding and language where there is a crossover, there is an intersection. And we have to have that in common now, because when we're going through some of this stuff, we need to start understanding what they want us to do, and they need to be able to understand what we want as database engineers and DBAs, okay? So the reason, why are we actually doing this? Well, we have a responsibility. We've always had a responsibility for the security of the databases in our charge, right? And I'm not just talking about people whose job title is DBA. If you are responsible for developing, deploying, and configuring databases or SQL instances, then you're a database administrator, right? Whether it's your job title or not. And in that scenario, you've got an inherent responsibility around the security. And so you should always take an interest, even as a DBA for 20 years ago, you should have been taking an interest in the network, even if it was just a case of, listen, guys, this is not public-facing, is it? It's not sat in the DMZ or anything. It needs to be in the private network, right? And we've always done that. And then the network engineers would say to us, no, it's fine, it's private, it's all right, it's all internal. I'd say, right, tick in the box, that's that done, from my point of view. Now I'll think about the SQL security, right? But we need to be able to leverage the agility of the cloud. Yeah, one of the greatest advantages of any cloud platform is the ability to deploy infrastructure, whether it's databases or VMs or whatever, very, very quickly. I want to say we don't have to raise tickets and wait for purchase orders to be raised and then wait for a hardware manufacturer to build a box. And all that's been cut out. Depending upon your internal processes, there might still be some POs that need to be raised or budgets need to be signed off first, and then various teams have to get involved. But the problem is that when you're creating these PaaS databases, there inevitably comes a point in the deployment process where it asks you about the network context for that SQL database or that managed instance. And in that scenario, if you don't have any kind of relationship with the network engineers, the deployment stops. You probably have to raise a ticket with the network engineers. They see the ticket and they say, right, we'll have a look at it in about 4 or 5 days' time and come back to you. And at that point, your whole deployment has stopped, right? And although that's still faster than the old days of ordering original equipment and hardware and getting it deployed to a data center, it's still a barrier, yeah? And it still reduces that flexibility and agility that really is one of the great advantages of any cloud platform, okay? So we need to understand these components, even if in the worst case scenario, it's so I can pre-warn my network teams to say, listen, guys, in a couple of weeks, we need to deploy a managed instance, and in order to do that, you need to give me a VNet to drop it into, okay? And then at least you can raise the ticket ahead of time because you know you need to do that, okay? So let's look at, let's actually get into the demos then. So let's talk about managed instance first because it's the most straightforward from a networking point of view. So here's my brilliantly rendered kind of network environment, right? Down in the bottom left, we've got our orange box representing our private corporate network. Whatever that looks like from a physical topology point of view, it's just your private network that you're used to. Over on the right half of the slide, we've got the Azure network, which, it's just massive, right? Covers all these regions worldwide, backbone between them, all the rest of it. Sitting between the two, we've got some form of secure connectivity. It's either going to be a leased line product called ExpressRoute, or it's going to be a software-based tunneling VPN, right, of some sort. Because when you actually deploy a managed instance, you have no choice about this. It has to go inside a private network. It goes inside a virtual network in Azure. When you deploy it, it says what VNet are you going into, and specifically what subnet. And if you can't populate that information or click the button to generate a new one because your network engineers are going to go, who's put up this new VNet? We don't know anything about the IP address range, right? So, but it always lives inside a VNet. Okay? So the thing with this is that because it's inside the VNet, it's no different to what we have at the moment. It's a private server, SQL box, sitting inside a private network. So in order to get connectivity from your management studio running on your desktop or your laptop, to be able to talk to that managed instance inside another private network, there's got to be some form of connectivity, right, between the two. Now, it could be that express route, and this is where I'm going to not really know what I'm talking about, but it could be that kind of express route where the engineers, the network engineers, have set up some kind of end-to-end connection between the VNet and your corp net, so traffic just flows. Or, if you haven't got express route, it could be this VPN type connection, right, which is what I'm going to demo in a second. And what the VPN connection does, just like it does, we're all used to using VPNs on our laptops, remote working, etc., it gives us that secure tunnel and connectivity into a private network. But it just so happens now that the private network is not you working from home connecting to your corp net. It's you working from home or in the office so you can connect to the VNet in the cloud, right? Now, again, this is not how you design a network infrastructure in Azure for an enterprise, right? But I just want to talk to you and explain to you about these different mechanisms for connectivity. So if I've got a VPN client that allows me to connect and have access to the VNet, once I'm inside there, I'm inside the private network, right? So I can just see and talk to the SQL box as usual. But I've got to have that secure connection. It's got to be paired between my device and the VNet gateway. Okay? Now, there is an alternative to this, and that is that I can deploy, did I click on? I can deploy a public endpoint for my managed instance, okay? And that does exactly what it says on the tin. For decades, we have been putting databases outside the corporate firewall, right? For very specific use cases, whether it's, caching for content management systems for web servers or, as part of some kind of third-party data exchange, whatever it is. We've always put SQL hosts outside of our corporate network for very well-defined and understood use cases. We don't do it often, but we do it, and we've been doing it for a long time. So in that scenario, where you need to expose the SQL host, the SQL managed instance, to the outside world, you have to deploy a private endpoint. Because what I can't do with the managed instance is move it physically outside the VNet like I could do with my own on-premise hosts. Yeah? It's always inside the VNet. So if I want to expose it to the public world, I have to deploy the endpoint. And the endpoint effectively gives you a second route to that box. It's still sitting inside the private network. You can still get to it via our secure mechanism on a private IP address. But the endpoint effectively gives it a public IP address that anybody in the world can then connect to, because that's the purpose of it. Yeah? So let's have a look at this in action. So if I can, how can I do this now? So what I'm going to do is I'm going to go to the portal, okay? And the first thing I'm going to do, although it's not actually the first demo, but the first thing I'm going to do is, sorry, I'm on the wrong box there. Let's go back to my dashboard. So I'm going to go to my managed instance, and I'm going to go down to the networking section. And I'm just going to quickly turn on public endpoint, because it takes a couple of minutes to deploy. So whilst that's deploying in the background, whilst we're getting that public IP address assigned in front of our managed instance, I'm going to flip over. I'm going to show you the private connection, right, using a VPN. So let's go to our management studio. Oh, no, just before that, I need the server name. So I'm just looking at the general details of the managed instance. I'm just going to grab the host name. And I'm going to go to my good old management studio. And I'm going to click connect. And type in the password. OK. And now, at this point, what I've got is Management Studio, fat client, running on my laptop, trying to connect to a managed instance sitting in a private network, right? This is like me trying to connect to, I don't know, a SQL box running inside the Barclays network. Yeah? There's no connectivity at all between my laptop and the private network where the managed instance is actually deployed to, right? And what I'm doing at the moment is filling dead time, waiting for this to time out so that we can then show you how we can connect. So that will take a second or two, won't it, to time out? So we're trying to come in through the bottom route at the moment, but I haven't got that bit of wet string in place between my device and the VNet gateway or the VNet, okay? So let's go back, and it's timed out, okay? So I get the traditional SQL message, you know, server was not found, blah, 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 okay? Now, what I'm going to do is we talk on the slide, or we've mentioned on the slide, about ExpressRoute or a VPN. Well, I've got a VPN client installed on this machine. So let me go here. If I go to my VPN, here's one I made earlier. And I'm just going to connect to that, and it'll take a moment to go through. OK. And then I'm going to go back to Management Studio, and I'm going to try and connect again. I just want to save that password, actually. Oh, I've done a typo. Can't read that. I've got my glasses on. Connection was unsuccessful. Typical. First demo's gone down the toilet. So let's try that one more time. Why didn't that go through? Did my VPN connect? Yeah, it says it's connected. That's saved. That's suggesting that it's getting through to the SQL box, isn't it? And I have got a stupid password on this because of the requirements of managed instance. OK, we're in. Right, brilliant. OK. So all I did there was enable the VPN client, right? I switched it on. Now, in reality, back at work, you're not going to install your own VPN client. It's unlikely, right? You're probably going to be given a VPN client by your network team. It'll get pre-installed on your device. And once you're connected, your traffic will go straight through. If you're not, if you're playing about with managed instance for the first time or whatever, and it's deployed inside a VNet outside of your corporate world, God forbid, there's a slide at the end that's got some links. There's a really easy article that shows you how to install a local VPN client for a specific VNet. And it's literally a little PowerShell script, right? And you run it on your laptop. It'll install a VPN client that's connected to a specific VNet. So what I've now got in this scenario is that bottom route is now enabled, right? Once I enable the VPN client, I've connected to the VNet gateway. That lets me get inside the network, and then it's just like I'm inside the network, because I am. So I can see the managed instance and work with it, right? Now, the public endpoint works a little bit different. So let's just see that in action. I'm just going to disconnect from the VNet so that you can see that I'm not connecting via that. And I'm going to go back to the portal, and I'm going to go back to the network settings. And there's my public endpoint button that I hit before, set enabled. And underneath that, I get an alternative host name, right? And if I take that over to Management Studio, and I do a connect, and I use the alternative host name that I've just got, OK. So I disconnected from the VPN, but I've managed to connect to the managed instance. But you'll notice that I'm using a different host name. Yeah. So can you see it's got public injected in the host name, right? So it is a different alias, and that alias has got a public IP address. So the scenario we're in at the moment with this is I've got both connections set up. I've got both a public IP address that I can use to access the managed instance, and I've got the bottom route. You know, are you going to have both? Probably, right? Because there's some actions, if this really was a public-facing instance, there'd be some actions that you would do against the public IP, but then there'd probably be more actions, particularly around the administration and configuration side, that you would do via the private connection, all right? But that's those two things. And the key thing about this is that this is absolutely no different than what you're used to with private networks and your traditional corporate networks with SQL, with SQL instances and servers sitting inside them. They might be outside the private network in your DMZ. They might not. The vast majority are going to be internal, right? This is no different. From a networking perspective, SQL managed instance is secure by default because it's inside a private network, okay? If you don't do anything, nobody can get to it. Yeah, the only way to get to it is if you've got the Azure rights to go in through the portal to change some kind of configuration. But nobody could spin up a management studio or another client application and connect to it, okay? Unless they're on a box inside the VNet. But that's the same thing, right? They're inside the same network. Okay. So from a networking perspective, that is identical to what we're used to, right? So let's talk about SQL database, because SQL database is a bit of a different beast, right? So the first thing is, here's my setup again. I've got my VNet sitting there. I've taken the managed instance out, because we're not going to look at managed instance again, because from a network point of view, we've seen it, right? But I've got my private network there. Now, when I deploy my Azure SQL database, it lives outside your private network. It is a multi-tenant PaaS system, right? It never lives inside your VNet, okay? You'll see later how we can make it be inside your VNet, but for now, it doesn't get inside your VNet, right? And it's got in front of it a public endpoint. Well, we've just seen a public endpoint with managed instance, right? The public endpoint allows me to come across the internet to connect to that SQL database, okay? Now, so let's just flick that on. So I can come in through the public endpoint. In this scenario, I'm not going through the VNet. I'm not necessarily going across a secure connection. This could be any internet-connected device connecting directly to your SQL database. Yeah? The connection is encrypted because SQL database enforces TLS encryption. If your client application does not support TLS encryption, you can't connect. You'll get an error. Management Studio automatically supports TLS encryption, right? But I'm coming in via an entirely public route. So the problem with this, obviously, is that my bad actors can also see the public endpoint. So this is the red rag to a bull to your network engineers and security teams, right? What do you mean? This is like putting my every SQL database out in the public internet. It's got my finance data, customer data, whatever it is, right? It's not quite true, because what we've actually got here is a firewall. There is still a firewall in this makeup. However, the firewall sits behind the public endpoint, right? So we've still got, at this point, we've still got all the components that we're used to. We've got a firewall to block traffic and things, and we'll see it in a moment. It's just that it's in a different place. The network engineers are used to it being wrapped around the network, right? And we've taken it away from there, and we've put it directly in front of our database or our SQL host. Okay, so let's actually have a look at this in action. So let's go to Management Studio again, and I'm just going to disconnect from these two, and I'm going to go back to my portal. Oh, and it's signed out. Thank you. Oh. I'm going to my bits dashboard, so I've got easy access to everything. OK, so let's go to the SQL bot. So this is the actual SQL host, right? Whenever we deploy an Azure SQL database, it gets a host. There is a SQL instance as well, and you can have multiple databases attached to that host. So I'm at the host level here. I'm at the host level configuration screens, right? And what I'm going to do is I'm just going to scroll down to the networking section. Firewalls and virtual networks, right? Now, there's quite a few things on this page, but at this point, all I want you to focus on is this middle section here, okay? So what it's telling me is you've got a public IP address at the moment that I can see in the Azure portal. So this address here, 148, whatever it is, that is the public IP address of this laptop, right? Currently tethered to my phone, I think. I'm not sure. I don't think I'm plugged in the network. Tethered to the phone, right? Oh, did I do a typo? Sorry. Oh, no, there it is. So 148.252.128.128, okay? So that's the public IP address that it's showing me here. This currently empty table is a firewall, right? And there's a nice big fat button at the top that says add my client IP address. And when I click on that, my IP address appears in it, and I can click save to actually save that change to the firewall definition, right? And now that I've actually changed that, if I go to my SSMS, and I try and go to the, sorry, let me get the host name. Sorry, I actually wanted to show you that fail, and I've forgotten to do that, but. Okay, and I'm in. But the reason I'm in is because my device IP address has been whitelisted within the firewall. Yep. Let me go back to the firewall settings because we need to go in them anyway. Because it's been added here. So back on our slide, what we've got here is this scenario where the firewall still exists to block my bad actor, right? The bad actor can't get access to my SQL database unless his source IP address has been whitelisted. And after that, you know, this is just how it's always worked, right? Once I'm through the firewall and I'm on the network, I then get challenged by SQL. Have I got a server login? Does it map to a database user? Have I got permissions, right? It's just that the firewall has changed location, okay? But this is a problem for our network security guys because as far as they're concerned, the database or the database server has got a public IP address, right? So we're going to see in the next section how we can fix that. But just before we do, just a quick thing about the firewalls. So there's two places you can implement the firewall with an Azure SQL database, either inside the database or at the SQL instance level. Now, we just did it at the instance level through the portal. If you want to do it at the database level, you've got to use T-SQL, right? There isn't a UI at the moment in the portal for doing it. But whichever you use is kind of irrelevant because all you're doing is inserting records into system tables, either in the master database, if you're doing the instance firewall, or a system table inside the database. Right? So why would we do this? You know, what's the order? Well, you know, up until 3 or 4 years ago, when the other components that we're just going to talk about in a moment were introduced, before that, this was the only way of doing your network isolation for your databases. Yeah, we still wanted firewalls, but we managed them inside the database or at the SQL instance level. Okay? There's some advantages to doing that even now, right? Those advantages are mainly around portability. If I've defined the firewall whitelist, the whitelist of IPs inside the database, and I back the database up and restore it to another host, it's got the same firewall settings, right? Those firewall settings are transportable. They move with the database, right? However, I can't think of any other advantages. And in reality, these days, very, very few people do this because this is for a number of reasons. Imagine, you know, what you're effectively doing here is putting a firewall in every database or on every SQL instance. If you've got a lot of instances and many more databases, that becomes an administrative overhead, right? Not only does it become an administrative overhead, but it becomes an administrative overhead for you. This is not the network engineer's job anymore. You can imagine yourself sitting down and having a conversation with them and say, hey guys, we're going to use a Azure SQL database, but that means we're going to take over responsibility for the database firewalls or for the firewalls in front of the database. You know, and as you walk out the door to gales of laughter, they're just not going to hand over that responsibility to you in most organizations, all right? So this is a problem for a lot of organizations, yeah, unless they're using very cutting-edge sort of modern application architectures born in the cloud-type architectures, right? But for the vast majority of established organizations, this is just not going to wash, okay? So we've got a couple of things that help us deal with that, okay? The first is service endpoints. So this is our current makeup at the moment. We've got our public endpoint that anybody can see, but we know there's a firewall sitting behind that that only allows whitelisted traffic through. Okay? Now, what we've got is an option called a service endpoint. And the service endpoint is deployed, we have to say injected nowadays, right? Is deployed inside the VNet, right? And what it effectively acts as is a bridge through to the SQL database that you created the service endpoint for. And what it effectively then does is it allows any traffic from inside that VNet, and I'll be specific here, actually it allows any traffic from inside a subnet within the VNet through to your SQL database, all right? And on that picture, it looks like it's bypassing the firewall. Okay, that's not strictly true, and we'll see why in a moment. So let's go to, I've got a virtual desktop, if I can find it amongst all my screens. No, that wasn't it. Was it gone off? Oh, it's flipping died to death. Bear with me a second. Let's go back to my dashboard. Oh, in fact. So what I'm going to do now is I'm actually going to go onto a VM which is inside the VNet, right? So, and this is actually the same VNet where our managed instance was deployed, but that's kind of irrelevant for this. Have I got a different IP? Yeah, let me just, sorry. So we have just-in-time access for RDP set on, so I've got to request my IP address to be whitelisted every time. So let me try that again. And I hope I can connect, because all the other demos are based on the VM. There we go, OK. Oh, wrong password. Going through. OK, so let's get on to this. So this is a virtual machine running inside a VNet, right? My managed instance is still outside, yeah? So the two are not connected at this point. So if I go to Management Studio and I try and connect to my database, to my PAS database server, yeah, I immediately get an error telling me this device has not got access, right? Because I've not been whitelisted in the firewall, right? I've hit the public endpoint, though. So it knows, it doesn't tell me that the server doesn't exist. It says, well, there is a server here, but you've not allowed in, right? So that's why I get this different sort of error message. But it doesn't alter the fact I've got no access to it, okay? So what I'm going to do now is just get rid of that. I'm going to go back to the portal, and I'm going to go back to my SQL database. And I'm going to go to the firewalls. And this time, rather than entering a specific IP address down here, I'm going to click this button to add a virtual network. Okay? And this is a service endpoint. SEP, I'll call it for short. Okay? And what it says is, OK, I'm going to create you a service endpoint. But what I'm doing effectively is I'm giving access to a subnet within a VNet to this database. I'm doing this from inside the firewall configurations of the SQL database server. Okay? So I can only see one network because this is my demo environment. You may see lots in the real world. And this is the specific VNet, sorry, the specific subnet where my VM is running. Okay? So I'm going to click OK on that, and that'll just take a moment to go through. There we go, that's gone through. So I'm going to go back to my VM. I'm going to click Connect, and I'm in. Right? No changes on the VM side, no changes to the network, actually, but I made some changes on the SQL side. Okay? Now, what I'm going to do now is I'm just going to flip back to my desktop and just show you something else. If I go back to my Management Studio here, and I try and reconnect to that same host. Oh. I'm in. right? So let's just have a quick look at the slide and see what's going on here. I've got my virtual machine, my VM, running inside the private network. It has used the service endpoint to connect to the database. But what I've still got is my public endpoint. So anybody who's whitelisted in the database's firewall can still get in from the public endpoint. So a service endpoint does not get rid of the public endpoint. In fact, all that service endpoint is a shortcut for adding a whole bunch of IP addresses to my firewall. And the IP addresses that it's added is the IP addresses for the subnet that I said, this is the place to put the service endpoint. It's nothing more than a shortcut for a bundle of IP addresses and to add them quickly into your firewall. Okay? Now, the flip side to that is, let's go back to our portal and say, well, this is no good. The security guys are going to go mad, right? I've still got my public endpoint. If I tick this box here in the firewall settings for the SQL server, this denies access from all public networks. And in fact, it gives you a warning underneath saying if you do this, you can only connect from a private endpoint, right? But I'm just going to save that. Oh, it's not touch. So bear with me 1 second. Is that saved? Okay, I'm going to go back to my VM. Did I save that? Sorry. There we go. Sorry. I'm going to go back to my VM, and I'm going to try and connect again. So what I've tried to do now is to remove the public endpoint, right? Because that's what the security guys don't like. But I'm going to connect to that instance again from inside my VNet, trying to use that service endpoint. It doesn't work, right? And the reason for this is, exactly as I've just said, the service endpoint is just an object that contains a bunch of IP addresses that has now been added to the firewall, right? So what that means is that from a traffic flow point of view, let me find the slide. This picture's wrong, and what it actually looks like is this. The service endpoint goes via the public endpoint, right? Because all it is a bundle of IP addresses. So the service endpoint only works if the public endpoint is available. So this is probably not your solution. The service endpoint is just a mechanism for, bulk loading, effectively, whitelisting IP addresses into your SQL database firewall. Okay? So we have an alternative option, and that's called a private endpoint. So this is what we've just seen, right? I've got my public endpoint available. I might be using a service endpoint or not to actually get access from inside the VNet, but that's kind of irrelevant from a security point of view. I've still got to have that public endpoint available, and that's a problem for my security guys, right? However, I've got this alternative called a private endpoint, and the private endpoint gets deployed or injected into the VNet, and it allows traffic from inside the VNet to access the database, right? So what? What's different between that and what we've just seen with the service endpoint, right? Well, let's have a look at this actually going. So the first thing I'm going to do is go to the portal, and I'm just going to tidy up some bits and pieces. So I'm going to just enable the public access again so we can see that in option. I'm going to remove the service endpoint. Oops, go away. So that you know I'm not coming in via that. Come on. Okay. And I'm going to, and then I'm going to create the private. Okay. So, and I'm going to create this, and then we're going to discuss it. Oh, cancel, need to save. Okay. I'm going to deploy a private endpoint quickly. Takes a few minutes to deploy, so whilst that does, I'm going to fill it, right, when we're going to talk about what the private endpoint actually is. So I'm still in the screens for the for the SQL instance. I'm going to click on the private endpoint. I'm going to give the endpoint a name. SQL DB private endpoint. It's going to tell me that's already been used because I've been practicing the demo. Okay. I'm going to tell it which region the target VNet is in. So I happen to know this is West Europe. This page, next page, is already pre-populated. I'm doing this from inside the SQL instance configuration screen, so it knows that this is going to be a private endpoint specifically for SQL traffic. In my head, I don't know if this is true, but in my head, this is a bit like making sure the right ports are open in the firewall, right? It's not enough to have the IP addresses. You've got to open 1433 or whatever it is that SQL's talking on. So that's what this is doing. But it's pre-populated because I've done it from inside the SQL environment. From a networking engineer's point of view, he can do all of this and create these private endpoints from the network management screens, but he'll have to manually pick which service a particular endpoint is for, effectively saying which ports are going to be opened, right? Then it's asking me, OK, which is the private network? Now, again, as I said, I've only got the one network in my lab environment. There are 3 subnets inside this VNet. I happen to know that my virtual machine that I'm using for the demos is in this one at the bottom. OK. And then I'm just going to click on tags, and I'm going to click create. OK. Now I'm just going to, that will take 2 or 3 minutes to deploy. Just while it's doing that, I'm going to quickly go to my remote desktop. Okay, I'm going to try and connect again to the SQL instance server. Yep, I get an error again as I expect. But I just want to show you this. So in a command window, I've just run an NS lookup, right? I'm not a network engineer, but my understanding is NS lookup, simple tool, give it a machine name, a host name, it'll tell you the IP address it's going for, or vice versa. Give it an IP address, and it'll tell you what the IP address resolves to. The important thing to note here is that when I've told it that I want to connect to a machine called this, a SQL instance called this, actually, DNS has resolved it to a machine name called CR4 West Europe 1-A da-da-da-da-da. And it's got an IP address of 104.40.168. This is the public endpoint machine. The public endpoint that we've been talking about that's a problem in front of the database, it's just a VM. Right? It might not be a VM, it might be a container, I don't know. But it's a machine sitting in front of the SQL databases. So the public endpoint is not your database. The public endpoint is a gateway. So whenever you try and hit a database server that is called something.database.windows.net, it will resolve to one of these public Azure SQL database endpoints. And that machine there, CR4 West Europe, whatever it is responsible for taking your call and then forwarding it internally on a completely different port, but forwarding it internally to your specific database. And it's at that point that the firewall comes in, right? That's why the firewall can't be in front of the public endpoint. The public endpoint is a gateway for every Azure SQL database, not just yours, but everybody's. Right? And it's responsible for forwarding the traffic through to the individual databases. So that's why the firewall sits between them. Okay? So what we're proving here is that, is my network engineer's nightmare public IP address. Right? So let's go back to it. Man, I finished deploying it, but let's have a look. It's still going. So let's go back to the slide and try and fill for another minute or so. Okay. So just to recap, we're trying to do that private endpoint so I can get my traffic through. We've just been on the VM. We've seen that the VM could not connect. I removed the service endpoint. The private endpoint wasn't deployed yet, so there was no connectivity, or rather, the VM's IP address is not whitelisted in that firewall, okay? And that's why the traffic was blocked. If I went back to my laptop and tried to connect, I could still get through. The public endpoint is there, et cetera, et cetera. I'm deploying the private endpoint at a moment. Hopefully, that's enough filling. Yep, there we go. Oof, magic. OK, so let's go to the, so we've deployed it. So let me just move my notes down here, sorry. OK, so let's go back to my remote desktop session. OK. And now I'm going to try and connect to that machine again. Fingers crossed this goes through. And I'm in, right? And if I look at my NS lookup output, if I rerun exactly the same command, oops, go away. Notice down there that I'm no longer deploying to that CR4 West, or I'm no longer hitting that CR4 West machine. I'm hitting another machine called SQL Bit SQL Server .private link, right? which is a private link alias for my SQL instance that's hosting this database. And look at the IP address. It's no longer 104, which is a public IP address. It's 10.0.1.17. I know, because I built this thing, I know that is a private IP address from inside the VNet where my VM is deployed. So what I've done now is effectively, I have created a private endpoint, a private IP address for my SQL database. And that private endpoint now lives inside my VNet, meaning that any traffic looking for that machine can go to that purely private IP address and get to the database. Manana, from a network engineer's point of view, right? Database hasn't got a public endpoint anymore, or at least it's got a private endpoint, because if I go back to my desktop and I go to my management studio here and I try and reconnect, let's disconnect, and I'm just wondering now whether I switched off something that I shouldn't have done. But let's have a look. Yeah, I've gone in. That's for my desktop here, my laptop, right? I've only done half the job. I might have implemented a private endpoint that's put a private IP address in front of the database server, but I've not switched off the public endpoint. I've still got 2 routes into it, right? So deploying the private endpoint is the first thing, and the second thing is getting rid of the public, that public endpoint. So if I go to the portal and I go back to my firewall settings, and I tick this box here, deny public network access, bit small for you guys to read, but it does say in here, if you tick this box, you've got to have a private endpoint. Otherwise, there's no way for SQL traffic to hit the instance. So I'm just going to apply that. Yeah. I go back to Management Studio on my laptop and try and reconnect, and it fails. Yeah. Server doesn't exist. So what I've done now, I've removed the public endpoint, so a bad actor can't find a server, regardless of the fact that there's a firewall behind that server. I'll rephrase that. The bad actor can't find the public endpoint, regardless of whether there's a firewall behind it or not. There is no public endpoint. Now, the only way to get to that box is if you're coming in from the VNet via the private endpoint. The private endpoint lives inside the VNet. Right? This is not the same as a service endpoint that just injects a bunch of IP addresses into the firewall. This has fundamentally changed traffic routing to the SQL instance. It's got a private IP address. We just saw it in the command prompt, right? So how do I get from my laptop then to that actual managed instance? Sorry, to this SQL database? Well, remember what I've just said is you've got to have traffic coming from inside the VNet. I've got a mechanism for getting this laptop inside the VNet already. I've got my VPN. So if I switch on my VPN again, which gives me access to that private network where I've just deployed the private endpoint, yeah, and I've got to do one other thing, I'll explain this in a moment. I'm just going to flip back to the desktop. So this is the private IP address, 1.17. I'll just show you this working, and then I'll explain what I'm doing here. And now I go to Management Studio on my desktop, and I try and connect again. I'm in. My VPN client has allowed this device to connect to that private network. Inside the private network is a private IP address from my SQL database. So when we look at the slide, this picture is true. That traffic does not hit the firewall, because as far from a networking point of view, the SQL database server is inside the private network. There is no firewall between the private network and the database that's just been injected into it, or at least an endpoint for it has. Okay? So the only way, therefore, for me to connect to it from the outside world is to get into that private network. And this is the other difference with service endpoints. Service endpoints, apart from just being that whitelisted block of IP addresses, they only allow connections from inside the VNet. Private endpoints, as long as you can get into the VNet, you can get through via the actual service endpoint. Okay? So private endpoints is really what everybody's doing now. Okay. Now, we've been talking about SQL, but these principles are the same for pretty much all the PaaS services like storage accounts and everything else, right? This is what the private endpoint does, okay? And if you want to explain to your network engineers how you can secure your SQL database, it is a private endpoint, NS lookup, showing them that it's now got a private IP address in their own specified IP address range. I've only got a minute left. There's a quick summary here, but all I want to say is, by default, everything is secure, right? Because SQL databases are, managed instance we saw at the beginning, always inside a private network. Yeah? SQL databases are always behind a firewall, and there are 0 whitelisted IP addresses in the firewall by default. So by default, everything is secure and isolated. Okay. I've run out of time, which is good, because it means you can't ask me any networking questions. So there we go. Thank you very much, guys. Feedback, please. Oh, there was a question?
Like Power Platform, or will it fail because Azure services aren't within my VNet?
Yes, is the short answer. So the question was, can I use private endpoints with something like Power Platform? And the short answer is no, because the private endpoint has to be deployed inside your private network, right? The Power Platform is quite weird in that it's this big software as a service platform that kind of sits outside all of this stuff. However, pretty much every PaaS system, like storage accounts that have got these public endpoints, they all support private endpoints. Yeah, so wherever we have those public endpoints, you can create a private endpoint that can be injected into your. So you probably usually end up with multiple endpoints inside your VNets, right? One for your storage account, one for SQL instances, one for Synapse, whatever else it is, right? Okay. Yeah, please, shout out.
What about these instances where you need a public-facing SQL server?
Yeah, so, 20 years, I mean, it's a long time since I've done it, but I remember projects 20 years ago where we were putting database servers outside our network. We're putting it in a DMZ. I mean, obviously, you are very careful about what data is actually stored on there. They were typically used for caching metadata or master data lists for websites and stuff like that, So I won't say it's an everyday task, but it's certainly not uncommon, right? Yeah, and in that, exactly. Yeah, you don't bother setting up a private link. As your SQL database is public by default, right? Okay. If there are any questions, feel free to wander up, grab me. I'm going to be packing my stuff away. So thanks, guys. Have a good day. If you're coming to the party, enjoy yourselves. Enjoy tomorrow if you're coming along for the free day.